Okay, hi everyone. So we're going to be carrying on with sequences today, and we're going to be carrying on with looking at quadratic sequences and working out the nth term for them. So the ones we're looking at today, they're slightly harder, but they're pretty similar to ones that we were looking at yesterday. So it's quadratic sequences, so it's the second difference that'll be the same, not the first. And then we'll be following that four-step method that we looked at yesterday of working out the nth term. So the first step for working out this one, so we've got our sequence here, 3, 8, 15, 24, and that's all written out for us already. So step 1 has already been done. Step 2 was to work out the difference and then work out the second difference. So going from 3 to 8 we've got 5, going from 8 to 15 we've got 7, going from 15 to 24 we've got 9. So there is a pattern there, but it is still changing. But the second difference, that's plus 2, that's plus 2. So we've got our second difference now, and that's going to be 2 each time. So when we know that, we know that step 3 was to halve the second difference, and then that tells us the coefficient of the n squared term. So we know that it's going to be 1 n squared because we've got 2 as our second difference. We halve that to get 1, so the number that goes in front of the n squared is a 1. So we've got 1 n squared. So what we're going to do then is write out that sequence. So we've got when n is 1, 1n squared would just be 1. When n is 2, 1n squared would be 4. So basically this is the squared numbers, 1, 4, 9, 16, 25. So we've got our n's at the top, we've got our 1n squareds. So what we need to do now is we're going to work out what the adjustment is to get to from our 1n squared to our sequence. So we work out our adjustment, and when we did this yesterday we just got the same number each time. So let's say it was 1 each time, we'd have 1n squared plus 1. But today it's a little bit different. So if we get our adjustment, so for the first one to go from 1 to 3 we've got plus 2. To get from 4 to 8 we've got plus 4, and 9 to 16 we've got plus 6. So we've got plus 2, plus 4, plus 6, plus 8, plus 10. So we can see that we don't, what we don't have is just a constant number. But we can definitely still see a pattern there. So what we need to do now is we're going to work out the nth term of this sequence. So we've got a difference of 2 each time. So it's going 2, 4, 6, 8. So we've got a difference of 2. So the nth term of the adjust bit will be 2n. And then to work out our sort of plus extra bit at the end, we go back to our 0th term. So we get 2 back, that'll just be 0. So it'll be 2n plus 0. But because it's just plus 0, we don't really need that. We can get rid of that bit. So we've just got 1n squared plus 2n. So our nth term for the sequence would be 1n squared plus 2n. Or because 1n squared, we don't need to write that. We can just write n squared plus 2n. And that would be our answer for this one. We've worked out the nth term of this quadratic sequence, and the reason why this is slightly harder than what we did yesterday is because of this step here. We're looking, it's not just a number at this point, it's another sequence. So we're adding our quadratic sequence here, the 1n squared, to our other sequence here, 2n. So our final answer is those two sequences added together. So we're going to do a couple more of examples on this because it is a bit harder, and it is worthwhile that we do this. But these are the hardest ones we'll see at this stage. These quadratic ones, they're the toughest ones because it's quite a few steps. But we're going to get plenty of practice with it. So I'll go through a couple more examples. If you want to go and have a go at one on your own, that's fine. Or if you want to skip to the next example and have a go at that one on your own, that's fine. But if you want to stick around and watch the examples, I'm going to go through 2 more. So we've got our answer there. So this next one, we've got 3, 7, 13, 21, 31. So step 1 was to write out n and to write out our sequence. So we've got n is 1, 2, 3, 4, and 5. And our sequence was 3, 7, 13, 21, 31. So we've got our n, we've got our sequence. And what we're going to do now, we shouldn't really draw a line there, is work out the second difference. So 4, 6, 8, 10. sure some of you have spotted the pattern already. So second difference, 2, 2, and 2. So we've done step 1, was writing these out. Step 2, finding the difference. So we've done 1, we've done 2. So to work out our second we've worked out the second difference. Step 3 was to halve the second difference, and that is our coefficient of n squared. So we've got a second difference of 2. So that means we're going to have as our sequence, the coefficient of n squared is 1, because that is half of 2. So we've got 1n squared. So now we're just going to write out 1n squared. So we've got n is 1. So 1n squared will just be 1, because 1 squared is 1. 2, so we've got n is 2, so 2 squared is 4. So that will be 4, so that's there. Then 9, 16, 25, because we've just got one lot of n squared. So whatever n is, we square it. So we've got 1n squared. And then the next thing we need to do, so we've done step 3, which is doing the coefficient bit. So we've done step 3 now. The last step was working out the adjustment, and then we need to work out the nth term of that. So adjustment. So our adjustment. So to go from 1 to 1, that's an adjustment of 0, so that's nice and easy. Oh, sorry, 1 to 3, adjustment of 2. To go from 4 to 7, that is 3 is our adjustment. From 9 to 14, that is 4. I think I'm seeing the pattern. 16 to 21, that is 5. And 25 to 31, that is 6. So we're going from this to our original sequence and working out what we need to change it by. So we've worked out our sequence of adjustment. Now we just need to work out the nth term for this. So we know our nth term is going to be 1n squared plus, and then whatever the nth term of this adjustment is. And then we've got our sequence. So we start off, we work out the difference. So we can see we've got a difference of 1 each time. So that tells us it's going to be 1n plus. And then to work out this extra bit, we work out the 0th term like we did when we're doing linear sequences. So that would be 1 would be our 0th term. So it's 1n plus 1. So our final sequence, 1n squared plus 1n plus 1. So we can see why it's a bit harder than yesterday. We've got 3 terms now. So yesterday we had something n squared plus just a constant, but now we've got an n term as well. So we've got n squared plus n plus 1. Because if we've just got a coefficient of 1, we don't need to write that. So it's a little bit unneat, but we're following just the same 4 steps as before. The key difference is down at this step, where we have to work out the nth term rather than just working out whatever the constant is and adding that on. So we end up with n plus 1 rather than just some constant. So I'm going to go through one more example. If you're feeling confident, feel free to go have a go or have a go at the last example on your own. So skipping on to that now. Okay, if you want to have a go at this on your own, feel free to pause the video now and have a go, but I will start working through it. So step 1 was to write out n and to write out the sequence. So I'll start out writing n. So we've got 1, 2, 3, 4, 5. I'll just write out the first 5. I don't think I need to write out all of them. And the sequence was 5, 13, 25, 41, 61. So done step 1, we've written out n and we've written out the sequence. Step 2 was we need to work out the second difference. So got 8, 12, what's that? So 16, 20. So we've got, it's changing by 4 each time. So 4, 4, and 4. So we've got our second difference. So second difference is 4. So we've worked out our second difference. So step 3 was use half of the second difference, and that is our coefficient of n squared. So half of 4 gives me 2. So it's 2n squared. So this is just the same every time. When you've worked out the second difference, you halve it, and that gives you the coefficient of n squared. I can't explain to you at this stage why that is, because we don't do the maths required for that until A level. So you just have to take my word for it. This does work every time with quadratic sequences. and if you do A level, you'll see why. So 2n squared, we need to write this out now. So n is 1, so 1 squared is 1, so 2 times 1 squared is 2. So when n is 2, we've got n squared, which is 4, times 2, which is 8. When n is 3, we've got n squared is 9, times 2, 18. N is 4, we've got n squared is 16, so 2n squared, 32. And lastly, we've got n squared is 25, 2n squared is 50. So, brilliant. We now just need to do our adjustment. So we've done steps 1 to 3. So we can tick off them. Step 4 is work out the nth term of the adjustment. So like with the last two, this is going to be a sequence in itself, and we're going to need to work out the nth term for this. So we've got 2n squared to go from 2 to 5. Our adjustment is 3. To go from 8 to 13, adjustment is 5. 18 to 25, adjustment of 7. I'm sure some of you have spotted the pattern by now. 32 to 41, adjustment of 9. 50 to 61, adjustment of 11. So we've got our adjustment sequence we need to work out. So we know that our sequence is going to start 2n squared, so I'll put that over here. And it's going to be plus whatever the nth term of this adjustment is, because that's what we're adding on. So our adjustment is, 3 to 5, so our difference is 2. So that tells us it's going to be 2n. And then our last, our 0th term would be, so again back 2, that would give me 1. So that would be 2n plus 1. And that is my nth term for the adjustment. So our final answer is going to be the 2n squared sequence, this bit, add my adjustment sequence, 2n plus 1. So we've got our final nth term for this whole sequence, 2n squared plus 2n plus 1. And what's good about these is you can check for the first couple. So if you've got your final answer, you can check it. So if we've got 2n squared plus 2n plus 1, if we want to check that it works, we can check for n equals 1, what would we get? So we'll do n squared, so that's 1 times 2, so that's 2. We've got n, so we do 1 times 2 plus 2, and we've got plus 1, so that gives us 5 for our first term, which as we can see is correct. And you could check it for all of these, but I'm not going to. So if you want to check, you can do, and in a test I would recommend checking the first couple at least, but I'm happy if you don't check these ones today. Oh, so I'm going to do one last one then, just the more the merrier on practice. If you're feeling confident though, feel free to go ahead and have a go. So step 1, write out n and write out the sequence. So n, got 1, 2, 3, 4, 5. Sequence, we've got 2, 3, 6, 11, 18. So we've got our sequence there. So we've done step 1. Step 2, find second difference. So 1, 3, 5, 7. So our second difference, 2, 2, 2. So we've got a second difference of 2, we can tick off that step. So step 3 was we halve the second difference and we use that as our coefficient. So our second difference was 2, so we need to halve that to get 1, and that tells us the coefficient of n squared. So this is always the way we do it. You work out half the second difference, that tells you whatever number goes in front of the n squared. So we know that our nth term sequence is going to start off 1n squared. And then we write out the sequence 1n squared. So n squared is 1, so that'll be 1. In fact, we've done this one in one of the earlier examples, so I'll just write this one out. So we've got 1n squared, now we work out the adjustment. So we go from 1 to 2, that's an adjustment of 1. Going from 4 to 3, that's minus 1. So we notice we're going from a big one to a small one, so we're adjusting by 1. Minus 3 this time. Minus 5, so you might see a difference with this one than some of the others. minus 7. So we can see that our adjustment goes negative. So it doesn't change the method, that's still what we're adding on, it just happens that we're adding on a negative number this time, because we're adding on minus 1, minus 3. So basically all it's going to do is it's going to change the sequence we end up with. So we need to see what's our common difference, what are we doing each time. So minus 2, minus 2, minus 2. So what that tells us is our sequence is going to be minus 2n. And then to work out the extra term at the end, the plus whatever, we find the 0th term. So to go back one, we're going to add 2, so that'll be 3. So it'll be minus 2n plus 3. So our final sequence would be 1n squared minus 2n plus 3, or just n squared minus 2n plus 3, because you don't need this one, because it's just in front of the n squared. So n squared minus 2n plus 3.